Hey everyone, Professor Hank here. Today we're going to take a look at how we can make decisions in Java programs. Specifically, we'll take a look at relational operators, logical operators, and the if statement. So let's go ahead and get started. So to make decisions, we'll need a set of operators known as relational operators. And these operators let us determine if a particular object comes before another object. So the operators include less than, greater than, less than or equal to, greater than or equal to, or not equal to. So, for example, we can use these to determine if x is less than y, if x is greater than y, if x is less than or equal to y, if x is greater than or equal to y, if x is equal to y, or x is not equal to y. So each of these relational operators is a Boolean operator, so they will evaluate to true or false. So for example, is 1 less than 2? This is true. Or is 1 greater than 2? This would be false. Or is 1 less than or equal to 2? This would be true because while it is the case that 1 is not equal to 2, it is less than 2. Is 1 greater than or equal to 2? This is false because 1's not greater than 2 and 1 is not equal to 2. Is 1 equal to 2? This is false because 1's not equal to 2. Is 1 not equal to 2? That is true because 1 is not equal to 2. So how are we going to use these operators? We're going to use these operators by employing a decision structure, the if statement. So the if statement has a syntax where we use the if keyword, followed by parentheses, and inside these parentheses is going to be a test expression that is going to be made up of relational operator or some combination of relational operators. So if this test expression evaluates to true, then we'll be able to execute a statement or set of statements. So we'll put inside of opening and closing curly braces some set of statements we want to execute if and only if this test expression evaluates to true. So if that's true, the block of statements will execute. If it's not true, then that block of statements is going to be skipped. So let's see what that looks like. So if we go into our main and I create a variable x and I initialize it with, say, 1. If I then have my if statement, I do something like this, is x greater than 0? And then I put inside this block here something like system.out.println. I could say something like x is greater than 0. And then after that if statement, I'll do something like goodbye. Now if I run this, pilot run it, you're going to see in the output, x is greater than 0, goodbye, because x contains 1. Our test expression evaluates to true because 1 is greater than 0. So we print out this statement, the if statement's finished, and then we print out our goodbye. Now, what happens if I initialize my x to 0? Well, in this case, this is going to evaluate to false because 0 is not greater than 0, and therefore this entire block gets skipped. So let's see that. We're going to see only the goodbye because this evaluated false, skipping this block, and then we moved on with the rest of our program, printing out the goodbye. Now you can put multiple statements inside this block. I could do something like system.out.println, hello, for example, and the entire thing would get skipped in this case because x contains 0. But if I initialize x to say 10, well then that would evaluate the true. And so the entire block of statements will execute. So you can see x is greater than 0, and you can see the hello, which is the result of lines 33 and 34 executing because the test expression on 31 evaluated true. And then on line 37, we do our goodbye. And then of course, if x was -1, -1 is not greater than 0. So that's going to evaluate to false. So that entire block will get skipped. And then the only thing we're going to see in the output is going to be the goodbye, right? So let's go examine that output. So there is the goodbye. Now, optionally, we could just place a single statement after this test expression. And if this is true, then just the one statement will execute, and then we'll continue on with our program. So if you want multiple statements to execute based on whether or not that test expression is true, you got to put it in the curly braces. You have to make a block. But if you only have one statement, you can optionally just do this. And you'll see that all we see is the goodbye because it's evaluated false, skipping this statement. But if we set it to say 1, then you'll see that single statement executes. Now be careful to remember to have those curly braces, because this is a easy mistake to make where you forget those. And even though the test expression would evaluate to false, you're still going to see this second statement because it comes after the if statement in this case, right? So you're going to see the hello, goodbye, no matter what, even though the test expression evaluated to false, because that only applies to the following statement or block of statements. So if we want them both to be conditionally executed, they have to be within a block. So you'll see here that that's going to fix our problem. So that's an easy bug to have crop up. So now you see, since this is false, both statements got skipped. You can see that in the output down here. So with that example, what we have is if true, do something, otherwise don't do something. So if our test expression is true, do A, otherwise don't do A. Now we can have a situation where we say if true, do A, otherwise do B. And so to do that, we're going to add this keyword else and then another statement or block of statements. So now if this test expression is true, we'll do A, otherwise we'll do B. So one or the other is going to happen. So let's see that in action. System.out print line, we'll just say X is greater than 0 or X is not greater than 0. So in this case, either this is going to happen or this is going to happen. One or the other. One will get skipped and the other will execute. And then we'll continue on with the rest of our program. Now in this case, X is set to -1. So this is going to evaluate to false. So this first block will get skipped. And then we'll kick down to the else block. And we'll see X is not greater than 0. So let's examine that output. You can see X is not greater than 0. And then once that block is done with the else, we go down and execute the goodbye. Now if X was in fact greater than 0, let's say it was set to 5, we run it, then you're going to see that X is greater than 0 because this is true. So this block executes, the else block gets skipped, and then we print out our goodbye. So you can see X is greater than 0, and we print out our goodbye. Now, we can also chain test expressions. So how do we do that? Well, I can put in here an else if with another test expression. So I could do something like else if X less than 0. So now, if this is true, this statement will execute. But if it's false, then we'll go down to the else if and we'll do another test. So if this is false, but this is true, then this will execute. But if this is true, then this will execute, and then we're done. The rest of the whole structure is skipped, and we go on and we continue with the rest of our program. So let's see that in action. So since X was initialized with 5, you're going to see that it is true that 5 is greater than 0. So we're going to see X is greater than 0, but then this is going to get skipped, and then we see goodbye. So let's look at that output, and you can see that's exactly what happened. 5 is greater than 0, so we print out the X is greater than 0, we skip the else if part, and then we go right on to the goodbye statement right there. Now what happens if X is less than 0, say -2? Well, then this will be false, so this will get skipped, and then this will be true, so this will execute right here, and then we'll continue on with the rest of the program. So let's examine the output, and you're going to see that that is in fact the case. X is not greater than 0, goodbye. But what if X contains 0? If X is initialized as 0, well then this will be false, and this will be false, and we'll continue on with the rest of our program, right? So let's see that. So we're only going to say or see the goodbye. Now what if instead I wanted to test to see if X was equal to 0? Well, I could do that. I could do another else if here, and I could say X is equal to 0, and then I could do, system.out.println X is equal to 0, right? And if I do that, then the first two test expressions will fail. The third one will be true. So we'll execute this statement, and then the goodbye will happen. And we see that. But think about it logically, X is either greater than 0 or it's less than 0. But if it's neither of those, there's only one other possibility. Nothing else can be true but that X is equal to 0. So in that case, if this is false and this is false, this will always be true. There's no way for it not to be true. So why test for that anyway? So we can just delete that if part, this will evaluate to false, this will evaluate to false, and so we can kick down to this last else here, and we're going to get the same. Okay, so what this else does is it causes the statement or block of statements that follow it to execute if all of the test expressions before it evaluate to false. And you can chain as many of these if-else ifs together. So I could do another else if here. Let's say I want to test specifically for 1. Then I could put another statement in here, and it could be something like system.out.println x is 1. And then we can run it. So this is a totally valid, syntactically valid structure. And in this case, what we're going to get, well, since x is 0, false, 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 and then we kick down to the else, and so you can see x is equal to 0. Now, what if we put x set to 1 and ran this? Are we going to see x is equal to 1? No, we're going to see x is greater than 0. Why? Great question. Because since this is true, the block that's attached to that first test expression executes, and then the rest of the else's get skipped, and then we move right on with the rest of our program. So if you wanted to test for this one particular edge case, you might want to put this all the way at the top, right? Put it at the top in a place where it can be first detected. And then we can take this guy and move him down here. So now we'll test for our special case at the very, very, very beginning. And if that fails, then we'll continue on. So just got to get the logic right in situations like that. So now you can see in the output, x is set to 1. Now let's take a look at logical operators. So what are these? They are and, or, not. So the first two allow us to chain together test expressions so you can check for more than one condition. So let's see what that would look like. So I could do something like this. If A is less than B and B is greater than C, for example. Now, in order for this to evaluate the true, this side will have to be true and this side will have to be true. So you've got test expression here, you've got test expression here, and they both have to be true in order for the entire thing to be true. Now, with the or, only one of the test expressions needs to evaluate the true, not both. So if this is true, then the whole thing is true. Or if this is true, the whole thing is true. Or if both of them are true, the whole thing's true. The only way this will evaluate to false is if both sides are false. Okay. Now, what does the not do? What the not does is it simply flips the Boolean result of the test expression. So in this case, let us say that A is set to 0 and B is set to 1. Now, if we were to just look at this test expression right here, this would evaluate the true because 0 is less than 1. But what happens is this not flips that. So the overall portion here, the overall test evaluates to false. So this block would get skipped. So let's see that. System.out.println. This is skipped. So if I run that, you're going to see only goodbye, right? Because this evaluated to true, the not flipped it to false. So since the whole thing's false, the block gets skipped and we continue on with the rest of the program. It can be very confusing. You can usually write your test expressions so that way you don't have to incorporate a not, but it's a way of asking the question, is it not true that A is less than B? Of course, we could always just rewrite this to say B greater than or equal to A. They're logically equivalent. Sometimes it might make more sense in your head one way than the other. And then it's up to you how you want to write that. Okay, the less confusing, the more simple you write it, the better. But sometimes you might want to write it one way or the other. Now, we can combine all of these things, all these ideas. So let's do C equals 2. So I could do something like this. I could say, if A less than B or not C less than 0, something like that. So is C less than 0? So this would be false because 2 is not less than 0, but the not will flip it to true. And at this point, we're done because I only need one side to be true, right? So you're going to see this is skipped. Okay, now of course, A is less than B, so that's true. So in this case, both sides of the logical OR are true. We can also do something like this. We could say, well, if B is greater than 0 and B is less than 10. Okay, now if we do that, these are going to get evaluated first, followed by the and. So both of these have to be true in order for the entire thing to be true. So if this entire thing is going to be true, then that means that b is both bigger than 0 and b is less than 10. So what does that mean? If b is greater than 0 and less than 10, then b is between 0 and 10. Between. It's a form of range checking. So you can see b is between 0 and 10. Now, what if I set b to 0? Well, then this is false because b is not greater than 0. So this will be false and we're done because both sides have to be true in order for the entire thing to be true. So we're not going to see b is between 0 and 10 because that evaluated to false. We're only going to see the goodbye. Now, if I had done greater than or equal to 0, well, then this would be true and b less than 10 would be true. So the whole thing would be true, but it's more accurate to say that b is from 0 and less than 10, something like that. B is from 0 and less than 10, or b is greater than 0, or b is at least 0 and less than 10, right? So drawing out a number line on a piece of paper can help you get this straight in your head. Now, if I wanted to determine if b was from 0 through 10, b is some number from 0 through 10, then this is how I would write it, right? Because if b is 0, then that's true. It's from 0 through 10. If b is 10, then that's true because b is from 0 through 10. B is greater than or equal to 0, and b is less than or equal to 10. So if b is 10 in this case, then this can evaluate the true, and we're going to see our output. Now let's take a look at one more thing you can do with if statements, and that is nesting if statements. So what is that going to look like? Well, it's one way. It's a way that you can do two tests one after the other. So you could do something like this. You could say, well, if A is less than B, within the block that follows that if, you can ask a follow-up question. Oh, okay, well then if C equals 2, then we will print something out. So maybe we'll say system.out.println, ha, something like that. So the only way in this case that we're going to see the ha is if this is true and if this is true. So this will happen first, followed by this. So you can have any kind of statement, as many statements as you want, within the block of an associated if or else. So I could do something like this, system.out.println, entering, if A less than B. And then I could have something following that, like exiting if A less than B. So this will execute here. That'll evaluate the true because 0 is less than 10. We'll then enter the block associated with that if, print out entering if A less than B. And then we'll do another check. Is C equal to 2? True, because C is initialized to 2. And pay very close attention. This is 2 equal signs, not 1 equal sign. It's a very common error that students will make, and I still make to this day because, your math classes, whenever you're doing just plain old arithmetic or whatever, you would just use a single equals, right? Remember, a single equals is assignment. Double equals is testing for equality. But anyway, so this will evaluate the true. And so then we will execute this statement here. It'll print out ha. Then this if is done. And then the next statement will happen where we'll print out exiting if A less than B. And then I'll do a little system.out.println goodbye. All right. So then if I run this, we're going to see the entering if A less than B, the ha, the exiting if A less than B, and the goodbye, just as we described. Now, if we set C to 1, well, this will evaluate the true. We'll see this, but this will get skipped, right? The system out print line ha will get skipped because 1 is not equal to 2. And then we'll see the exiting the if, and then that'll finish off this outer if here, and then we'll see the goodbye. So let's see that. So just as we described. Now, an interesting thing about this is this has to be true and this has to be true in order for this statement to execute. So if we get rid of these guys, and the only way this statement right here will execute is if this is true and this is true. Does that sound familiar? Hopefully it does. We just looked at the logical operator and, right? So I could rewrite that. Instead of nesting it, I could rewrite it like this. And that's totally fine. And actually it's better because you don't want to nest too much. You don't want to go too deep, right? So now you can see that we don't see this, the ha, all we see is the goodbye because why? This is true, but this is false. Now, if I made that 2, we ran it, then you'd see it because they're both true. So that's everything that I have for you this video. As always, if you're a student of mine and have questions about any of the content in this video or any of the other videos in our courses, please feel free to stop by my office hours or email me via Canvas. Thanks for watching, and we'll see you next time.